Arti madam.
Yes, sir.
Exactly 11:30 ಗೆ principal madam Sharwad madam permission ತಗೊಂಡು start ಮಾಡ್ಬಿಡಿ.
Okay, sir.
So your voice is very audible from very distance. It's not so clear.
ಕೇಳಿಸ್ತಿದೆ ಈಗ?
Ha sir, now it's okay.
It's clear.
Bharati madam, take the permission and you begin.
Yes, sir. Good morning, all. Good morning, Principal Ma'am. Good morning, HOD Ma'am. Shall we start with the program?
Yeah, good morning. Good morning. Wish you all the best. Start, please.
Thank you, ma'am. Sherwad, ma'am.
Good morning. You can start.
Yes, ma'am. Thank you, ma'am. So once again, good morning, all. Today we are conducting national level training program on e-draw chemistry organized by Chemistry Department, SK Arts College and HSK Science Institute, Hubballi. I request our head of the department, SN Sherwad Madam, to welcome the gathering. Over to you, ma'am.
Thank you, Rashmi. Good morning to all. Respected Principal Madam, today's resource person, all my colleagues, and dear students, welcome you all. First of all, I would like to welcome our beloved Principal, Dr. Uma Nerle. I welcome you, Madam.
Thank
I
you, ma'am.
heartily welcome today's resource persons of this program, Dr. Siddesh and Dr. Nagvini. I welcome all my teaching colleagues. I also heartily welcome to all participants across the country. KLE Society Belgavi has made a humble beginning in the year 1916 with selfless service and dedication of 7 teachers fondly known as Saptarshi. All of us owe a great debt to those noble souls, now nearly 300 institutions across the world. SK Arts College and HSK Science Institute belongs to KLE Society and established in the year 1952, and in 1966 science wing has started. The institution was established with a view to educate the rural and urban youths of the surrounding areas in humanities and pure science. It is situated at a strategic place in Hubballi city of northern part of Karnataka. Now, I would like to brief about E-draw chemistry. What is the necessity of chem sketch or E-draw chemistry? Under the pandemic situation, the students learn how to write equations and chemical structure by using chem sketch application. It is a program used to create and modify images of chemical structure. It is also allows molecules and molecular models displayed in 2 and 3 dimensions to understand the structure of the chemical bonds and with the nature of the functional groups. ChemSketch is used by hundreds and thousands of scientists around the world to quickly and effectively draw molecules and reactions for use in documents, electronic lab notebooks, to search databases, and also to generate accurate names from structure and to predict properties of spectra. I am very much pleased to introduce today's potential guest speakers of our own department and college, Dr. Siddesh and Dr. Nagavini. Dr. Siddesh has completed his MSc at Chem University, Shimoga, completed his PhD in synthetic organic chemistry in the year 2014 at Chem University, Shimoga. He has worked as coordinator in various fields. He is the life member of Indian Society for Technical Education. He has published 14 papers in international and national journals. He has presented papers in 2 international conferences and 6 national conferences. At present, working as an assistant professor in SKA and HSK Science Institute, Hubballi. Dr. Nagavini is second resource person of this today's program. She has completed her MSc with gold medal at Chem University, Shimoga. She did her PhD in Center for Nano and Soft Matter Science, Bangalore. She is SRF and JRF scholar at Center for Nano and Soft Matter Science, Bangalore in the year 2008 to 2010 and 2010 to 2014. She was guest speaker for various events. She has also patented for her own on cholesteric liquid crystal and device thereof. She is also member for Materials Research Society of India and Indian Liquid Crystal Society. She has published 11 research papers. At present, she is working as an assistant professor at SKA and HSK Science Institute, Hubballi. Such a wonderful resource persons amongst us. By this, I conclude my introductory speech and give way for further proceedings. Thank you. Thank you, one and all.
Thank you, ma'am.
Thank you, ma'am. And also a very warm welcome to you too, ma'am.
Bharti, excuse me.
Yes,
Please
ma'am.
check audio. Audio. Please.
Yes, ma'am.
Participants are requesting audio is not clear. Siddesh, please check.
It's okay, madam. We can hear you.
Okay, go. You request audience to check their audio, please.
Participants, please check your audio. Okay, we have two resource persons, Dr. Siddesh MB and Dr. Nagvini NG with us. Participants, if you we have two sessions. If you have any queries and questions, you will text in the chat box. At the end of session, speaker will answer to your questions. Now, I request Dr. Nagvini NG ma'am to begin with the first session on hydrochemistry on aliphatic hydrocarbons. Over to you, ma'am.
Thank you, Bharti madam. Am I audible?
Yes, ma'am.
Okay, I'll just share my screen. Very good morning, one and all. I welcome you all once again for this national level training program on hydrochemistry. Myself, Dr. Nagveni NG, Assistant Professor at SK Arts College and HSK Science Institute, Department of Chemistry. This is the first session. In this session, I'll be talking about the aliphatic hydrocarbons, only chain lengths and like that simple molecules and what are the basics involved in this hydro, that I'll be talking. Before going to the software and before going to draw the molecules and reactions, we'll just know why we need this hydro, means why we have to learn this drawing skills. Or why we have to use the chem sketch or chem draw. What are the importance for the quick and effective draw of molecules and reactions? You within a fraction of seconds, neatly you can draw the molecules, you can draw the reactions, everything for better of your display purpose or any presentations, and to use in the documents and in the presentations. If you are appearing for any PPT presentations, poster presentation, with a handwritten, you can't present that one. It will be very odd to present like that. So you can draw in these softwares in ChemDraw or ChemSketch, and you can use that one in your documents or in your presentations. And also, for example, somebody wants to write a book or publish some papers, research articles, anything, they can draw and they can draw their entire reaction, synthesis, whatever methods, and they can put it in their books or e-journals, research articles, whatever. And to search the databases also, These are very, very useful. If you, I'll tell you that later. If you go for a paid version, there are inbuilt molecules, all the details, and you will get the online details about where it is published, who has synthesized this one, who got patent about these molecules and all. And to generate accurate names, we are going to synthesize some new molecules. We want to know IPAC name, like normal, like with the rules and all, we want to know the accurate names. These are the very, very useful tools for that. And to predict the properties, to like density, volumes, and then 3D visualization, and all the properties you will get automatically. And also you can get the spectra. For example, proton NMR, then carbon 13, like that you can get it very easily. Am I audible, right?
Yes, ma'am.
Okay. So we'll see the softwares, what and all, like we can get it from online, offline. So to write the structures and reactions, we have so many options. Like we get the sources, like online sources also available and offline sources also available. Here I have shown you online sources. Directly click these links, or you can copy these links in the website, Google Chrome. It will give you an online facility, just an online facility. You can't download the software in these category, online sources. Like ChemDraw, Perkin LMR is there. It is a very famous company. It has established this one. Then ChemSpider, then KingDraw, then ChemSpace. In this, what I'm stressing, you can't download these things. Only you can access online. And then offline sources. Offline sources are there like ChemDraw and then ChemSketch. ChemDraw is a paid version. You have to get it, purchase that one. Obviously, some colleges will be purchasing that one. Higher versions are available like that. Still, you want it for yourself. Okay, so for example, students, research scholars are there. They can't pay that much money. They can go for this last option. That is ChemSketch version. That is offered by ACD Labs. Okay, this is a freeware. Freeware means they are giving it for free for the students, research scholars, and for the academic purpose. This is truly for the academic purpose and for the research purpose. And you have to give your authentication and all details. Then you can download it. They'll give you the key number they will give. You can download that one and you can use it. So let's go to now this one. You remember this one, acdlabs.com. We'll go and we'll see now how it works. Go to Chrome. Is it visible, this one window?
Yes, ma'am.
Okay. So just try write ACD Labs. ACD Labs. This one you go www.acdlabs.com. In this one, already I have selected this one, ACD ChemSketch download. Okay, so here directly it will go to this window. In this one you can see ACD ChemSketch download. This is a freeware, freely available, and then you can download first name, last name. It has asked some authentication details. Okay, after filling this one, already I have downloaded, so again it won't come for me. Just I'll show you the details. See this one, fill everything, then give the download software. Remember, after giving you all the authentication details, then you give the download software. It will send one email to whatever email you have mentioned here. In this category, like you will give proper email, working email ID. There they will send you the key number. Then download software, it will ask you the key number or whatever you have received in your email. Then enter that one. Then proceed. They'll after going, this will take you to the next page. There they will give step by step how to install that one. It is like a normal software only. Just you have to download that one extension file. Then you have to run on your system. Then it will automatically store in your laptop or your desktop. You can use it freely. But freely means only like 50% or 60% of the material you will get it freely, but when you go for a paid version, you will get it more options. But for the research who are doing in the beginning stage, and for the students, it is not possible to offer that much money. So this is a very, very easy method. For example, like for students, they want to learn more things by doing trial and error. This is the best method. They can go for this one. So after downloading, it will come like this. This window you can get it. You go to wherever it is stored ACD labs. In that you select ACD Chem Sketch. You will get this window. Okay, this is a freeware, and you can play around your chemical structures or molecule. Just I'll start with the, see, already you can see in the left side, you can see the atoms, carbon, hydrogen, nitrogen, oxygen, and so many are available. And in this one, different types of bonds are available. It is like already selected. This option you can see in the toolbar, second line. This option is already selected. If you select the carbon, then it will give you the methane. Directly it will give you the methane. If you want to extend this one, okay, you want to extend the chain length, just click on this one like this. You can go on clicking on this one, then it will extend. Then what about you want the double bond or triple bond? Okay, what you have to do, very simple. On the single bond, you click once again, it will give you the double bond. And then if you want the like you want another like a triple bond, something like that, click once again, it will give you the triple bond. Just do whatever you options are there, no, in Word file, Control Z, it will go back like this. So it similarly, like very friendly software. It is very friendly software. For the selection of this one, you click this one on the second toolbar, second line, you select this one like this. Entire molecule will be selected. Okay, then you can play around this molecule. Okay, then I want to change the atoms. For example, I want alcohol group with nitrogen, with fluorine. Just select this one on the left side, whatever the toolbar is there, select this one. Oxygen, if you select OH, it will automatically take the valence also. If you only give the oxygen, it will take with the H only. Then you want to extend it. Okay, again you want to give the aliphatic chain length. Then what you have to do, just click on this group where you want to change it. It will give you the extension. You can what you have to do, just take whatever the atom or the group you want to insert, click on that one. It will change it automatically. Like that you can play around. And then so many, like chlorine also you can insert, like sulfur also you can insert. Like this you can play around the structures and the molecules. These are some basic properties. Then what about, I'll show you. We want like a different bonds, okay, like chiral atoms. See in this second line toolbar, they have given the wedge bonds, stereo bonds. See, go there, whichever bond, just click on that one, it will change to that one. Similarly, you can go do it for this bond also, or else select the next one, then you click on this one, it will give you. Then again you select this one, then shortcut is there to clean up the structure, like to show the bond angles and the bonding line neatly. You can do the press F9. After selecting your molecule, then it will do the cleanup of the structure. And then another property is there to numbering. You can see here on this one, show or hide atom numbers. Like I want to give the numbering for the atoms. So for that beginning, what you have to do, just you click this one, it will give like this. Okay, the central is 1, then 2, 3, 4, 5, like this. Apart from this, if you want it for the hydrogen also, if these are present, no, for that also if you want, select this structure. After selecting structure, go here in the second line only. There is an option 3D optimization. It is called 3D optimization. Do this one. So it will show elaborately. It will elaborate your structure. It it will give like a C, all the 3 hydrogen atoms also in a elaborate manner. Then you give the numbering. Entire for the including carbon and hydrogen also, it will give you the numbering for the atoms. And then I'm just doing Control Z here to show the different properties. And then you can go here in this second line, there are options 3D, select this one, rotate and resize also is there. And then third option is there, 3D rotation. I'll show you how it works. Select this one, 3D rotation. So see, you can play around. Just hold your mouse in one position. Then on the structure, you can play around like this. Okay. So it will give you the 3D structure also. And if you want the up and down molecules like that, you want to see like this, you can play around this one. And then second option is there, rotate and resize. Rotate and resize. One red plus sign will come. After that, what happens? You just drag your molecule like this. On the plus sign, red plus sign, you can rotate your molecule and you can place it whatever the way you want in the reaction. When you are writing the reactions, complete entire reactions, you want it in a proper way, bond angles, and you want OH to the right side or functional groups to the left side, then this will be very helpful. Okay, then we'll go to next option. See, on the right side, we have the some templates available, right side. So, in this one, table of radicals are there. See, this one, chains are there. This, if you select this one, for example, chains, directly it will come like this. You can play around this one, and then you can select another one also, like N5 is there. Select this one. Or already you are drawing something, and then you select this one. Any chain you select and click on this one, it will take it automatically. That chain length it will take automatically. Similarly, we want to do the some like acid groups are there. For example, aldehyde groups are there. We want to introduce at the end acid groups. For example, click on this one. It will convert it into acid group. For the typing of the reactions, it is very, very useful. Within a fraction of second, you can write the entire big molecule. Instead of putting oxygen, hydrogen one by one, this is very, very helpful. Then also, we have the so many other like ions or molecules complete, like nitro is there, cyano is there, like that. Then you can add anything, acetate is there. Anything you can just click on, it will add. Or you can select this one. I want to change this one entire group, CH3 group. Then whichever you want, just click that one. It will add there. Okay. Then in this molecule again you want to change. Okay. In the year I want to introduce some new molecule, atom, something like that. You can change this one. Select that one. It will change automatically. Like this. It is templates are there, like these are like inbuilt options are there, you can use that one. Then you are drawing some amino acids or like some reactions are involving these one, directly you can take this precursor, directly you put it and you can use it, this one. These are very, very useful. Then I'll show you. This is about the templates of the radicals. Then if you go for the tools are there, you can see one by one. I said clean structure means neatly it will present your structure. That is shortcut is F9. Then the 3D optimization already I shown. Here it is on the toolbar in the second line. And then we have a generate option. Generate name to structure. Name to structure. You can for example, select anything. This one I'll select. This one, we want to generate the name. Select that one, then go to tools, name to structure. It has given propane, like this. Then another options are there. You can see stereo descriptors are there. And then calculation, if you go, molecular formula. Before that, what you have to do, I'll just select this one. I'll show. This molecule I have selected. I want the molecular formula. I want the molecular weight. I want the properties in detail. So what you have to do, just go calculate molecular formula. It will show here like this. Then copy to editor, it will give like this. Then again select the molecule. Then molecular weight. It will show here. You can do the copy to editor. It will come on your screen. Or else I want all the properties. That option is also there. Density, surface tension, whatever applicable. No, it will give in all details like molecular formula, molecular weight, composition, everything. It will come one by one. All the details you will get about the molecule. Then you do copy to editor. It will be visible. It will be visible on your screen. See, it will be visible about that molecule in detail. Then we'll go to the, this is about what? Tools. In tools, we have got the this much options you can play around. And if you go to the template window, if you go, see this one, carbohydrates are there. If you select anyone, select one option. I have selected this molecule. Similarly, like that, you have template window. We have the chains are there. As I said, aliphatic chains are there. Directly, you can select anyone in this one. You can place it on your screen and you can use it. And then lab kits are there. These also you can copy and paste, and Newman projections, and then orbitals. Like if you want to show the 3D orbital formation and all, these are very, very useful. And many also are there. This you will find in the next session. Sir will explain in detail. And then this is about the template window. As I said, you can select anyone and you can play around. I'll just show anyone. You can take this one, take this structure like this. Okay, this is the options we get in a templates window. Then also is there table of radicals. This is shown in the right side of this window. Then periodic table is there. This is very interesting. You can see this one. If you select whatever the atom you want to know about, it will give you in this description box details. Okay, about the barium, you can see. You click anything, carbon, it will give you all the details. And then NMR spectra. It is more related to PG students. They'll be studying about the proton and NMR spectroscopies and all. This is very useful, where you will get the peak and what is the intensity and all. Then mass, then coloration. This depending on I'll give. This is about the very normal periodic table. If you give the metals and non-metals, it will differentiate. Blue color are the metals and yellow color are the non-metals. And then you want to know about the radioactivity properties like this. You can select and you can play around this one. Then in this one only, in periodic, okay, I explained, we get it, the NMR and mass, everything. You can select any atom and you can learn about that one. Then if I want to show you how to draw one chemical reaction, very simple chemical reaction I will show. For example, we'll do some esterification reaction. Let's say take the acid group. I want it as be acetic acid. I'll take it like this, acetic acid. This is my first reactant. And then I'll place the, here you can see in the second line of toolbar, all the options are there. I'll take the plus sign, place it. And then I want the alcohol group. Any alcohol group, just take this one. So I want the alcohol group in this position. I'll take the oxygen, I'll convert it. Or you can select from the templates also, very easy. You can go around and you can search and you can do it. And then I want this one, like anyone, any alcohol. Okay, I don't want to be specific. Then what you should do, select this one. You get it like this. Okay. I don't want to be very specific alcohol, so I've selected it as a R, any R, and then OH. So now this is like a reaction between acid groups and the alcohol. Okay, then I'll take the arrow symbol also easier, put it, and you have a different types. Okay, you can see if you click on the end of this box, you will see the different aromas. Okay, two-sided reversible reaction and all you can select, and you can do your like write your reaction whichever you want. Then now writing about the product part, what I'll do, I'll just select this one. You can edit that one easily. Okay, this one I want to edit this one. So now I want in this group what OR dash. Okay, so what you do, I'll show you the simple way. Click on this one. Then I want here O. Then this one as a R. Select in this one. I'm showing you in the left side. Then you click on this one. Then select entire structure. For the selection purpose, you have to select this one. Okay, so do the F9. Okay, now I wanted to place it in a proper way. As I said, you can use the second option, rotate. Rotate option you can use. Like this. So you can give you the names. By selecting, because I have mentioned R dash, it won't give you the specific name unless you give you with the like proper chain length or proper atoms and the labelings. Otherwise, it won't give you the name. And I want to, I have written the reaction. I want to label it. What type of reaction? You can select here. I'll show you once again. T is there, no? This one, text box. You can select this one. You can write this one. Like esterification. Okay, this one. Now what you do, simply now I'm done with, I'm writing up of the reaction. What I have to do now, I have to take it to the PPT or the Word file where you want to present it, where you want to store it. So what you have to do, select this one, just do Control C, copy, open any Word file or PPT, just copy it. This is very, very simple. But this option, because you have downloaded it and it is freeware, it is giving you the option copy and paste. But if you go it for the online sources, okay, beginning I shown online and offline sources. Online sources, these options are not at all available. Copy paste is not easily available. Only you can draw it there and you have to extract it from some other method. But in this downloaded version, this version, you can easily copy and paste wherever you want. You can do it in your slides or for making the posters and all. You can just draw whatever you want and then take it to the PPT or the Word file. It is very, very useful. And similarly, I want to show you this is about the freeware. Then if you have in your laboratory or department already, they have purchased. This is a old one, okay, whatever I'm showing. Advanced one is there, like version 12 and 13 are available. This may be 8 now. This one, options are little bit very, very less, okay. So we don't have that much options like in this one, Chem Sketch. So just I want to show little bit about this one. So we have to draw like this. Then we have to take the atom, which atom you want to present it, like this. And we have a similarly like a different bonds are available in the toolbar. You can use this one like this. And then chain length you want to mention, like I want a 7, mention 7, it will come 7 like this. So many like aromatics are there, ring structures are there, all are available, like lobes are available, different lobes. You can select whichever you want, you place like this, you will get it. And then similarly, like if you go for a view, you get the analysis window. This is not like in because this is a very lower version I'm using. It is giving very less options. It will give you like this. Paste means it will give you like this. Then what you can do, you can place it wherever you want. You can present it neatly like this. And then naming also it will give. Then we have another option. convert name to structure. Like I want simple ethane structure like this. It will come like this. Okay, say like you want to give naming for this structure, convert structure into name. This gives the structure name. And also we have another option, that is in this one 3D properties are there. Then proton NMR shifts you can get it. Okay, like this. Then intensity and where it will come. Here you can see this one. End it will be CH3. This is end CH3 always will be at a 0.96. Then about the second one 1.33 and 1.29. These are merged one. Similarly, you can go and find it. Carbon 13 also. That was about, I'll show you. This was about what? Proton means this was about the whatever the hydrogen atoms present. And this was about the carbons. Okay, end carbons and then next carbons like this. This is about the carbons. Okay, this is you will study basics in BSc also. Then in PG you will be like given the problems based on these. So you can learn from here. You can learn it from here very easily. So this is it. I'll just go back to my slide. Okay, so you can download from this ACD labs and you can play around. And then I want to give you some more information about some simulations software also. Lastly, some 2 weeks back, we did a program on student development program. In that one, we have talked about this one. You can find it useful. You can go to our college YouTube channel. There you find the programs, videos about these programs. You can go and watch it there. You will learn Ed Informatics. Note down Ed Informatics, Colorado. These are very, very useful for the students fraternity. You can learn from there about the 3D models, building of atoms and the molecules. With this, I'll end my session. This is like about only basics I have talked. And in next section, you will learn some advanced like big molecules, ring structures and all. Other person, resource person will be talking about that one. Thank you one and all. And I want to thank Uma madam, our beloved principal ma'am, giving this opportunity for me, first of all. And then I want to thank our HOD madam for supporting all the way and to organize this program, and all the faculty of our department. I thank you one and all. And finally, I thank all the students and then who are all present here. Thank you all.
Thank you, ma'am. The session was very interesting and all of us got good information. Thank you once again, ma'am.
Thank you.
Now we will begin with the second session. Dr. Siddesh MB, the resource person, will engage the second session on hydrochemistry on the topic aromatic and heterocyclic compounds. Over to you, sir.
Thank you, ma'am. Am I audible?
Yes, sir.
Okay. So, good afternoon, everyone. So, in this session, actually, Nagmani madam is in my presentation because she had given all the basic ideas of using and downloading all the Chem sketch thing. So, it has made me easy for my presentation because I will be directly going with the presentation. Yes. Can you see the screen? Okay. So, as Nagmani madam told, so the Chem sketch which is available in the ACD labs, you can just click on the link and you can download it as madam has told. Okay. So I'll skip all these introduction things Okay. So now I'll be just moving to the heterocyclic molecules or the aromatic molecules with respect to the thing which we are going to discuss here. So I'll be directly moving to the chem sketch thing. So after downloading, you will get a shortcut link like this. And if you double click on the shortcut, so the window of ChemSketch is going to open like this. Okay. So now you can see here all the options. Okay. So Nagmani madam has told you about the aliphatic hydrocarbons and the side chain hydrocarbons and all. Okay. So let's simply discuss the things. Okay. Here. So here before going to that, so have you seen this molecule? Can you see this molecule? Rashmi madam, can you see this? Instead
No.
of the students, you can just reply.
Sir, share the screen. It is not screen shared.
Yes,
Yes, sir. Visible.
it is visible now. So, do you remember this, which molecule it may be, or do you know, because this molecule is gaining more attention nowadays. That too, in this pandemic, it has gained more attention. This molecule. So this molecule is nothing but what exactly the DRDO people, our DRDO people has invented recently, and it is giving it is used as a medicine for our coronavirus. Okay, so this is what we call it as 2DG molecule. Now let's see how this 2DG molecule can be drawn in our chem sketch. Okay, so if I double click on this 2DG molecule, okay, so here it will directly shall go to our chem sketch, and can you see this is the 2DG molecule, so where the DRDO people has invented for the ours, and how we can draw this 2DG in our chem sketch. Okay, so this is already I have drawn here, so I'll just draw in front of you people how we can draw. So to draw this, it is not much difficult here, so you can just go directly to the tools here which are already available. Okay, the kits which are available, template windows, and you can just search for the carbohydrates. Okay, or you can just search for lab kits, DNA, Newman projections, orbitals, everything here. Okay, so now you can see here I have clicked on sugars. Okay, so there are many sugars which are available, which are looking like similar to our 2DG molecules. So I'll be just clicking on one of the sugar molecule. Okay, so you just see here, this is the sugar molecule
Yes,
which
sir.
I got.
Yes, sir.
Huh?
Yes, sir.
Share the screen once again, sir.
Screen share ಮಾಡಿ sir.
Screen share ಮಾಡಿ.
Yes, ಈಗ
Yes, sir.
okay, so this molecule is the 2DG molecule. Okay, so now we have to get the 2DG molecule in our chem sketch. How to get the 2DG molecule again? So in our chem sketch, you can see here on the top right, we have a template here. Okay, in the templates you directly go to sugars, because that 2DG is nothing but 2-deoxy D-glucose. Okay, so it is a sugar molecule. Okay, you just select any one of the sugar molecule which is available in the template, and you just click that, and here this is 2DG, and in this you can see, you compare these two structure here. So here what is going to happen in this carbon, we are going to have a CH2OH. So here we are going to have a H here. If you want the CH2OH, you just take this carbon and just click on this hydrogen and take this oxygen, and again extend that, you will get CH2OH indeed again. Or if you don't want to do it like that, okay, what you can do is you can just select the A option at the left hand, that is edit atom label. You can just click it and click on the hydrogen, and you can just type here as CH2OH. If you type here CH2OH, I already typed it, and I'll just insert it directly. It will give CH2OH here. Okay, so now what I'm going to do here, we have already H and OH, here also H and OH are there. Okay, but in 2DG we have both hydrogens here. So here one OH is there. Instead of OH, what we can take here, H I will take, I will put directly the H here. Okay. So now HH, OH, HOH. Okay. This is how simply we can draw the 2DG molecule. Okay. That is 2-deoxy D-glucose. Okay. Now, which is very important drug which is invented by our beloved renowned scientist from DRDO, and which is used as a drug for the coronavirus. Okay. So which is again simply synthesized by this molecule here. Okay. So what they have done is, so this is a glucose. Okay. So to this glucose, they have reduced this glucose. Okay. They have just removed an oxygen. This, they have removed an oxygen from this. Okay. So here what they have just did, they have just done, they have just removed the oxygen here. Okay. So this is what exactly, how exactly the 2-deoxy or 2DG has been synthesized here. Okay. 2DG molecule which was synthesized by our scientists. This is a glucose, and this upon again removal of oxygen from here, that is reduction. Okay. So we are going to get the 2DG molecule. So this is how simply you can put a reaction here. Okay. So this is one thing I just wanted to tell you people. Okay. How we can draw these things. Okay. Using the Chem sketch tool. Okay. And again, we'll be moving to one more here. So I'll be just copying from my earlier versions which I have taken. So this is one reaction scheme which I have drawn you. Okay. Which I have drawn again. Okay. Earlier also in the last week we have conducted one student development program. There also I have taken one scheme. Okay. How we are going to put for a research scholars. Okay. Or for any PhD students, those who are going, those who are doing PhD, particularly in the organic chemistry, they have to predict the schemes and they have to write the scheme. Okay, how they can write this schemes, okay, using a Chem sketch. So this will be like this, how they are going to write.
Screen sharing, Siddesh.
Yes. Yes. Okay. So now this is one compound. Okay, they have taken. So how you can draw this compound in this? Okay, let's see using a Chem sketch. Okay, this is what, to draw this compound, what they have taken, we need a benzene ring first. The benzene ring is directly available here. I'm going to take this benzene ring and put it here. Okay, and we have what you can see here. Okay, so what we can see here, here we have C triple bond N, okay, which is attached to this carbon of the benzene ring. Now we have to generate the C triple bond N. How we can generate the C triple bond N? So we can go directly here and search for the structure. If it is available, we can put here directly. Or this C triple bond N, you can search. You can just see here we have a C and cyano group. So you can take that cyano group and keep it here. Okay. So we got this molecule, and in this carbon we have a bromine. How we can draw bromine? Again, select directly from the atoms. Okay, and select bromine and extend that from this carbon here to this carbon. You add bromine. Yes. Now we added the bromine. Okay. So both these two compounds are same actually. Okay. This and this. Okay. If you want the name of the structure, okay, if you want the name of this structure, okay, so you just click on this, it will be selected as a whole, and here On the top, you have a generate name for a structure symbol. So you just give on that. This will give, this is a 2-bromo-benzonitrile. Okay. To this, what we are going to add, we have added in the scheme this molecule. In the scheme, we have added this molecule. So how to draw this molecule again, that we will see now. So this 2-bromobenzonitrile plus this molecule we have to draw now. Okay. So how to draw? So you can just see how many atoms are here. 1, 2, 3, 4, 5 here. Okay. So you just take carbon and go on just extending how many you need. 2, 3, 4. And what I'll just do simply is I'll take oxygen, I'll put to the second position, and here there is a double bond O. What I'll do, I'll just extend this and I'll just click this, it will become double bond O, and here instead of CH3 we have a SH. So take sulfur and just put here. So, and just click on this and give the clean structure, it will arrange like this. So here this compound we have generated. This is the same compound which I have written now. Okay. So, and if you want the name for this also, you can just click on the beside of that compound, just side by that compound, and give the generate name for structure. So what is this? This is methyl sulfonyl acetate. Okay. So again, what they are doing? So these two 2-bromobenzonitrile and methyl sulfonyl acetate, they have reacted with each other. So in presence of what? The potassium hydroxide to give this compound. Okay. So this is a benzothiophene derivative they have generated. Okay. How to generate? Again, by condensing these two. That is 2-bromobenzonitrile and methyl sulfonitrile. So again, I will draw this arrow mark symbol. Okay. I'll put it here, and on the arrow mark we need KOH. Just come to this, add edit atom label, and just click over here, and what you need to add KOH. Type KOH and put insert. So you will get KOH here. Okay. So now I will be just deleting these two. Yes. Okay. And we want to draw this structure, right? This structure, this is the product that we are going to get it from these two compounds. How to generate this compound? We have a benzene ring and we have a 5-membered ring attached to this. So take the benzene ring, keep it here, and attach the 5-membered ring. Which is available here, cyclopentane. I'll be just putting cyclopentane here, and so this should be double bond. Okay, just click on the carbon and just click on this bond, it will become double bond, and in this draw one group, and here you can see here 1 atom, second 3 atoms. Okay, from this 1, 2 and 3, and here I'll put just double bond. So for all these positions, what I need here, oxygen is there, here oxygen here, and there oxygen, and there CH3 is there, and in this carbon we need to have sulfur. So put sulfur here. Okay, and here CH3, instead of CH3 we have to have NH2. So this is the compound which we are going to get by the reaction of 2-bromobenzonitrile and methyl sulfonyl acetate. Okay, so you can just compare these two structures. These two are the same, the one and the same here. Okay, and if you want to generate the name for this, again click on this and give the name. It will give, this is methyl 3-amino-1-benzothiophene 2-carboxylate compound. Okay, so this is how we can draw the reaction scheme. Okay, so again this reaction scheme is further extended by the addition of hydrogen hydrate. So we are going to get this compound. Okay, so how we are going to again draw? So again it will be a take an arrow mark, and if you want to react with hydrogen hydrate, take nitrogen and just nitrogen, this will become NH2. This is the hydrogen hydrate that you are going to add here. Okay, and I'll just delete this. Okay, and you are going to get the compound 2 here. Okay, because whenever you are going to write the reaction scheme during your research or during your presentations, okay, you need to give the number here. Whatever the name you should mention in the theory part, you should not give the names directly in front of the compounds. Okay, so now we are going to draw this structure. To draw this structure, again, simply you need not to again begin with the benzene and 5-membered ring. You just copy the above structure and again Control C and Control V. So Control C and Control V. Okay. So here what has been replaced? Instead of OCH3, we got NH2 here. Okay. So how to get that NH2? Take nitrogen, NH, and then here again NH. You can just click this bond, it will become NH2. This is what we have synthesized. So again, just click this, give the clean structure as like this. If you clean structure, the structure will be arranged properly. So 6-membered, 5-membered, NH2 and CO, NH2, we are going to get this compound. Again, if you want to generate the name, you can generate the name for this structure. And you can see here, so from this structure, they are adding this compound, okay, and they are going to get this biggest compound molecule or biggest molecule. Okay. So again, how to get? Again, I will be doing the reaction. Okay. So further, you are going to add here. How to add this? How to add this molecule? So take one benzene ring and second benzene ring. In between the benzene ring, how many carbons you need to see? 1, 2, 3. Okay. So what I will do is I will take one carbon, second, third, and this from this third carbon it is directly attached to this carbon of the benzene, and this is a double bonded structure, and here we need to have one double bond, and here the instead of CH2 we have to have oxygen. Okay, this is what we are going to have. What is the name of this compound? We clean structure first and generate the name for this structure. Okay, so it is diphenyl propene 2-in-1-one. Okay, so this is what the compound which we are going to add to synthesize this compound. Okay, again you can see here this is a bigger molecule. Again it is it looks big. Okay, but to draw it is very simple actually. You need not to do anything. Take the earlier compound which you have synthesized, okay, and just Control C and Control V, it will be pasted. So here what we have to do is, in this we have to generate 5-membered ring, and we have to have, this is one side unbenzene ring, another one benzene ring we need to have. So I'll not do anything difficulty in this, I'll just keep it here. Okay, so for my sake, and what I'll do is I'll just delete this also. Okay, so now what I'll do is I'll take again the 5-membered ring. I'm going to put the 5-membered ring on the nitrogen. Okay, so first you have to draw the structure, then Marie just clean it. Okay, so one nitrogen we have here, one nitrogen we are going to have, and another nitrogen we have. I just added the another nitrogen here. There is a double bond. So this will be in a tautomerization. It will be in an NH form as well as C double bond N form. Okay, so I'll just make it to C double bond N form itself. Okay, so now from this, okay, we have to have one more bond here. Okay, so this is a CH3 which we are having, and here again we have to have NH. Okay, and we have to have here the benzene ring. Okay, so now what we have to have here, again nitrogen we have to have, and another nitrogen, and this should be a double bond. Okay, this should be double bond. Okay, and instead of this CH3, what we have to have? We have to have a benzene ring. Take a benzene ring and put it here simply. Okay, so this will give the simple structure. This structure, what for A to F is there, and this is both are same. Okay, so you can see here. Okay, and again if you want to generate the name, click on this, generate the name for this structure. Okay, as this structure is having more than 100 atoms, see, you just look here, restricted version, because in the free version we cannot give the name for the compounds which are having more than 100 characters. For that sake, what we have to do is, if you have a Chem draw also, you can just copy this and open ChemDraw. If you have a ChemDraw software, okay, I've just opened the ChemDraw software. I'll share you now. So this is a ChemDraw software. Okay. So I have copied the structure from a ChemSketch and I'll put in here and I'll be pasting in a ChemDraw. So this is what the structure which I have drawn in a ChemSketch. Okay. And here you can generate the name. Okay. Structure. Go to structure and convert structure to name. So here also name could not be generated for that structure it is giving. Again, as this is also a free version, so here it is also not taking because of the free version, the number of atoms are more. So in this free version, we cannot also name in this. Okay, but again, we'll try to have the NMR predicted NMR spectra for this. Yes, you can see here for your compound, this is the predicted NMR shifts. Okay, here at the bottom also we can have the delta values when you go for the NMR studies. So if you are a PG student, you will be studying about the nuclear magnetic resonance, and for our degree students, that in Karnataka University, Dharwad. So this time you people are having a nuclear magnetic resonance spectroscopy basics. So then we will discuss about this. So this what the value it is giving 7.78, 7.86. These are what we call it as a delta values which are coming for the protons. Okay, protons of this molecule. You can see here there is a proton in this. So this proton will appear at the delta value 7.78. Here this CH double bond CH proton it is going to appear in 7.33 delta value, and this proton is going to appear in 7.31 delta value. So this spectra whatever we are going to get, so this is just the probable spectra. Okay, so only the thing you can get, this is only the probability of the NMR spectra these softwares are giving. Okay, so the exact spectra will come only when you synthesize a pure compound and give it for the analysis. Okay, so if you are having a purest form of the compound, if you have synthesized, then you will be getting the spectra perfectly like this. Okay, so but there will be some little changes in your delta values might be there, little changes, not too much changes. Okay, so this is what I just exactly wanted to tell you. Okay, and so one more thing I'll be telling you people. So yeah, so in this, by using ChemSketch, you can draw how you can draw fullerene with respect to your carbon 20 C20. Can you see this? Bharti madam, kanta ide?
No, sir. Once again, share.
Okay. Yes.
Screen is not visible, sir.
Right. I'll just open it directly and okay now.
Yes, sir. Visible, sir.
Okay. So now you can see here. So I'll be showing how we can draw this fullerene carbon 20 with the carbon 20. Okay. So at the end of the session, and if you people have joined the WhatsApp group of this Google form which I have created, I'll be sharing you the manual of how you are going to draw the structures using the ChemSketch also. Okay, so this I have taken it from the manual of the ChemSketch. Okay, so how to draw this fullerene carbon 20? So I can see this. So this is the fullerene carbon 20 you might have come across. Okay, how to draw, because you just follow these things. Okay, here switch to the structure mode and delete any previously drawn structure if you have drawn in your ChemSketch, and from the table of radicals you can just select the cyclopentane structure which I have taken it for the drawing the earlier structure just now. And you have what you have to do to generate a fullerene. First write one cyclopentane and go on attaching the cyclopentanes like this 1, 2, and 3. Okay, and again continue to attach the cyclopentanes to all over this. Okay, so next what we have to do is we have to just join this carbon to the next, to the next, to the next, so that we are going to get this structure. Okay, and after getting this structure, okay, you have to draw CH3, CH3, CH3 on each terminal. Okay, and after that we will join this and we will be getting this fullerene carbon. So let's see how we are going to generate this fullerene. Okay, so again I'll be going to Chem sketch and I'll be deleting all the versions which I have drawn earlier. So for deleting, again just Control A and just shift delete. Okay, Control A and delete. So now we will draw fullerene. So I have taken cyclopentane from the templates which are available here. Okay, so just go on adding the cyclopentane. And you just observe here where I have added the cyclopentane. Okay, so I have added the cyclopentanes here. Okay, then by clicking this button, what I will be just doing, selecting this, I will be joining this from this carbon. I will be joining this from this carbon. I will be joining to this carbon, and I will be joining to this carbon. Okay, now I got this structure. Again I will be drawing CH3 here. One CH3, second CH3, third CH3, fourth CH3, and fifth CH3, and I will be joining these three H3s. See, look at this. Simply I have joined this. I'll just give the clean structure. Okay. Okay. So this is what we have got. Join it properly. Yes. Yes. Now we have got this. Okay. And if you select this and go to the 3D optimization. Okay. And now you see here in the 3D optimization, if you want to remove the hydrogen, you can remove it. It will be giving you the fullerene carbon like this. Okay, so you can see this fullerene structure. So as it is mentioned, okay, according to the procedure, simple procedure, we have done the fullerene that too with carbon 20 only here. Okay, so we can do similar structures, okay, where more carbons are there. Okay, and so that too it will be easy if we go with the paid version of the Chem sketch or Chem draw. So it is easy for us to draw those things. Okay, so again one more thing you can see here. So here you can see here creating how to create a structure of bicyclo 222 octane. So this is a simple structure how we can create a 222 bicyclo 2 octane. This is what exactly the bicyclo 2 octane is. For that, what you have to do is you have to take a cyclohexane which is already there available, and you have to draw CH3 molecules from this carbon. Again, one CH3 you just extend and join that CH3 to this. Okay, it will give you, this is a bicyclo 222 octane only. Okay, this is again how we are going to get simple one. Okay, this is the version of the this is tryptophan. Okay, so from this bicyclo octane, again the next step it is preparing tryptophan. Okay, tryptophan we can synthesize. How? Again, simply to this, go on adding benzene ring here. Okay, so and one more benzene ring, you will be getting the tryptophan. Okay, that also we will show. Okay, how we are going to generate here. So again, So I'll just resume this. One second, as it is struck. Yes. So here you can take cyclohexane, put it here, okay, and take the carbon molecule, select, and from this draw CH3, again CH3 you can draw, and again CH3 you can just draw here. This is what? This is the bicyclo-2,2-octene molecule that you're going to have this, okay. So if you give 3D optimization, again it will be coming like this. And if you rotate the structure, see, this is how you are going to have this, okay. This is what exactly, or how exactly your molecule is going to look. See, you can weave the 3D model also, okay. So here, now what we have to do is, again I'll give the clean structure. When you give the clean structure, so you are going to get the structure like this, okay. This is bicyclo what? Octane, okay. So from this, how to synthesize, how to prepare tryptophan that we have seen. Again, take one benzene and attach directly the benzene to here and to this and to this. This has become tryptophan, okay. This has become tryptophan. This is how we can draw it, okay. How we can draw it from the models, okay. Whatever the things which are available or whatever the structures, if you require, just observe it directly and you can draw it by using the templates also, simple molecules which are already available in the Chem sketch, okay. So like this we can draw many structures, okay. And in the last I will be going with one simplest mechanism, okay. So I just take this benzene ring, okay. So if you want to alter the bond, okay. So how? So because in the last student development program, somebody has asked, can we write the mechanism? Yes, of course you can write the mechanisms also, okay. So the simple mechanism I'll be just showing you here, simple here. So take the benzene, go to draw here again. So if you just want to move this double bond to this carbon, okay, what I'll do is I'll be selecting this arc, okay, arc. So how much you want to rotate the arc, you just select from this and select this arrow immediately, and I'll be selecting more bind. Okay, so I have drawn here, okay, you can see here. So now when this double bond is transferred to this carbon, what it will become? So we will be having this, okay, but there will be no double bond here, okay. So here, as the double bond is moved to this carbon should be having negative charge. To give the negative charge here, what I have to do is, on the left hand side you can just observe here there is an increment, that is plus charge, and you just click here, you will get the negative also, decrement, and put here. You can put directly, or you can just take the edit atom and you can just write minus symbol and insert, okay, and just move this symbol little downward, okay. So now we will be having this, okay. So again from this, what I will do is I'll take the arrow mark next, I'll be putting here, okay. So next I will be taking one more, I'll just take cyclohexane here, I'll put it here, okay. So now what I have to do is, again I'll be selecting this and this, So this double bond should be moved to here, then this minus sign will be moved to this bond to create a double bond here, and this double bond due to the electron density moving to this carbon. Okay, so going to this carbon, I'll show you. Okay, so for this, what it will become? This has become a double bond. Okay, so this carbon is going to become double bond here. Okay, and this carbon will be negatively charged. It is become electron rich now. Okay, so now I'll be putting the negative sign here. Yes, okay, and there is a double bond already which is there here. Okay, so this is what exactly the next compounds will be looking like this. Okay, so now what is going to happen? This minus will be moving to this, and this double bond will be moving to the next carbon. Same again, go to draw, select these two, and again this minus will be moved here, and due to electron rich, this carbon is going to give its electron to the next carbon. Okay, so now what it is going to happen? Go to structure further. Okay, take the arrow mark, put your arrow mark here. Okay, take the benzene, cyclohexane I'll take. So I'll make this as a double bond. As this electron is donating to this, okay, this will become double bond, and there will be a negative sign here. So again, I'll take this and I'll put it here. I'll give the negative sign, insert the negative symbol here. Okay, so again, finally, what we have to have? Yes, now here this minus is going to move here because there is no double bond. So this only will be moving here. So this will be moving to this. Okay, so by that we are going to have double bond here, double bond here, double bond here. So this is just simply how the resonating structures we can draw. And similarly, like this way, we can draw the rest of the things. And to give a bracket to the resonating structure, from where you require, from here, okay, from here to here you require. Just drag it and fill it, apply. Okay, so it's applied. Now you can see here how it is. Okay, and you can take this, you can copy this, Control C, and you can again paste to any Word file if you want. Okay, or any, you can see, you can paste it and you can look. And if you want to just alter some arrow marks, you can further go and alter here. Okay, you can further go and alter with this. Okay, if you want to move something, okay, the bonds, if they are not visible properly, you can move it and you can add anything. Okay, and this is simply with the benzene I have done with the simple mechanism or resonance structure to see the resonating forms. Okay, how the delocalization of bond is going to happen. Okay, so similarly, as it is asked in the earlier session, so can we draw mechanism? That's why I've just taken this example to give you the simplest things. Okay, so this is again with respect to all these things, that is tryptophan we can draw. Okay, so with this I'll be concluding my session. Okay, so if anything, if you want to ask, you can share. And what are the conclusion from this? Again, this chem sketch or chem draw, they are very useful to construct the structures, useful in understanding chemistry structures. We know the whole properties. Okay, so as already Nagmani madam has shared you people. Okay, so how we can draw the structures. Okay, if you have any queries, please you can ask. Parthe madam, over to you.
Thank you, sir. It was very interesting, and students will take more benefit of it. Now it's time for the interaction. So no questions in the textbook. So shall we move on to the next part, sir?
Yes, somebody has asked one question. Can we get spectral data from this software? Yes, of course, you can get spectral data for this from this software, but the only spectral data that we are going to get not from ChemSketch. In the ChemSketch, in the paid version of the ChemSketch, you will be getting the information of proton NMR, but not the IR spectral analysis that you are going to get. But instead of that, you will be getting the molecular weights and other things you will be getting. Okay, the other respective. But in the ChemDraw, if you copy the structure to the ChemDraw, and if you give the proton NMR, predict the proton NMR or predict the C13 NMR, it will be giving you the probable. Okay, so as I told you earlier, that the spectra which you are getting from the ChemDraw or ChemSketch, okay, they are only the probabilities. So the actual spectra, if you will be getting the same only if your compounds which you are going to synthesize is 100% pure. Okay, it should be 100% pure. Then only we will be getting the exact spectra which will be matching to your ChemDraw or ChemSketch. But it will be giving, as I told you, only the predictable values it will be giving, not exact. Yes. Any other things? Any other questions? If audience, if you are having any questions, you can raise your hand so that we will be unmuting you, or we will allow you to speak. You can just raise your hands if you want to speak.
Participants, any questions or doubts? You can raise your hand in the chat box.
Okay, madam, you move on.
Thank you, sir. Now I request our beloved principal, Dr. Uma Nerle, madam, for the presidential remark. Over to you, ma'am.
Yeah, thank you, Bharti. Thank you, Dr. Siddesh, Nagmani, and thank you all my dear students. Really, it was a wonderful session and effort made by the two resource persons. This was on-demand program because 15 days back we have arranged this program for the nationwide, and there was a lot of demand from the PG students. Some PG students are there, my previous students, like I can see the Floria and all. So Floria has requested. Can you hear me, Siddesh?
Yes, ma'am.
Yeah.
Yes, ma'am, we can hear you.
So many students requested. So on this on-demand program, we have arranged once again this program, and I think so students has taken the lot of advantage and benefit from this program. Though also within 2 hours, it is not sufficient to gain the knowledge, but the basic knowledge you all of you people have learned. You have the resource person contacts, and surely they will help you in future also. So please be in touch with us and please subscribe to our YouTube channel. Okay, so once again, I wish you for all the future success for a budding scientist, for PG students, I can say, and for UG students, you can aim for the such a PG courses where it is very useful for these all, because this is a pandemic and day to day we are learning something different new, and this was a great effort by the chemistry department and all the whole team. Always we, the KLSK Arts and HSK Science Institute, bringing daily new things in front of you. Please follow us on YouTube and Facebook channel. Stay home, stay safe. Thank you one and all. Thank you.
Thank you, ma'am, for your unbound love and enthusiastic support and motivational words. Thank you once again, ma'am.
Thank you, Bharti. Thank you.
Now we have come to the end of the sessions. It's my privilege to propose vote of thanks. Firstly, I thank today's resource person and organizing secretary, Dr. Siddesh MB, sir. Thank you, sir.
Thank you, ma'am.
I thank other resource person, Dr. Nagmani NG, ma'am. Thank you, ma'am.
Thank you. Thank you.
I thank our principal, Dr. Uma Nerle, ma'am. for unconditional support. Thank you once again, ma'am. I also thank our Head of the Department, Srimati S.N. Sherwad, ma'am. Thank you, ma'am.
Thank you.
I thank students all over India who have actively participated, and also I thank our own students. I also thank management, KLE Society, Belcome. I also thank my colleagues of chemistry department and all other departments who have directly or indirectly supported us. Thank you, one and all. Thank you once again. Stay home, stay safe.
Thank you, dear participants. I request you all to open your videos, switch on your videos so that we can take a snap.
And also feedback link is shared in the chat box. Fill the feedback forms. Participants, please fill the feedback form.
Excuse me, Siddesh. Siddesh,
Yes, ma'am.
at the end, please give your contacts so as to they can contact directly you people.
Sure, ma'am. Sure.
Yes, ma'am. Ma'am, I made a slide. I'll share now. After
Yeah,
photo session, I'll share it, madam.
Yeah,
After
please.
photo session.
Please.
Participants, switch on the videos.
Okay. Can we leave the meeting? Nagmani?
Yes, ma'am. Thank you, ma'am. Thank you for your support. Thank you. I would like to thank Sherwan madam and all my dear colleagues
Okay.
and all the student participants. Thank you. Thank you for being with us.
And dear participants, I've shared the details, contact details of both the resource person and the YouTube link of our college. Please subscribe to YouTube link so you can be updated, keep updated about the upcoming events, workshops, and student development programs. So please subscribe to our YouTube channel. You will get the notifications. Thank you. You can take the screenshot and you can note down.
Thank you, Principal Madam, given one good opportunity for department, Madam.